Hi, I am Andrew Rowland, and I will be talking a little bit about standardized work and how it can provide continuous improvement in the manufacturing field and in other walks of life. With standard work, the operators know how the job is supposed to be done and what the outcome needs to be. By knowing what the finished product needs to look like, the operators can see when errors occur. Therefore, they are able to fix any issues as they arise. Playing into this, leaders involved should not punish workers for not following standardized work, but should find out why they are doing it that way. Based on how the operator is working in regards to safety, the leader might want to modify the standardized work, therefore creating an environment of continuous improvement. Based on some research provided on Vector Solutions, I found that standardized work should lay out the steps for the workers in an easy to understand fashion by providing things like visual representations of how the job needs to be done, worksheets that show the process of manufacturing, examples of finished products, and clear instructions of how to complete the tasks. By teaching all employees how to read and study these documents, the standardized work should be carried out effectively and efficiently. There are three elements to standardized work that I will discuss in detail later in the presentation. Lean culture is hard to define in just a few words, as it encompasses so many things. One of those things being standardization. The Ono quote, shown here, is a great way to connect standard work to lean culture, as lean culture is all about continually improving and eliminating waste for company success. As I have put, without improvement, there is always risks for waste. If a company has the foundation for a good lean culture, standardization being included, then the company will likely see a successful lean culture with little waste, better quality, and safety. To achieve standardization, the manufacturers must keep the three elements of standardization in mind. Takt time is basically just the time it should take for an operator to complete their product. By keeping track of these times, the operator and leadership is able to identify defects in the product and are able to fix the issue. When I did my internship at Roper, we were working on a standardization for a new oven door, which took about a week to actually get a good time, since it was a new product. At the beginning, the operator was taking almost 5 minutes to put the door together. However, at the end of the week, his time was down to 45 seconds, therefore providing the manufacturers with a good standardized takt time to work with. Work sequence documents support takt time, as they show exactly how a product should be made. In-process inventory is a way to provide progress for products that will be completed and put into inventory. However, while it is in process and there are no value-adding processes being done, the product, or rather the time it is just sitting there, is considered a waste. This is a cool example that I found online of a standardized work chart for building a Lego wall. While it is not technically manufacturing in the most technical sense, this chart is very similar to something one might see in a factory detailing how an operator would follow step by step the written and visual steps to get the final product. In this chart, one would follow the written and visual instructions in order to build a sturdy Lego wall. At Roper, I saw many good examples of standardization. The first was a quality issue we had with an operator. On the particular line, both single and double ovens are built. The singles did not require any modifications, but the doubles required two pieces of foam strip to help with the airflow within the oven. However, the operator was not putting foam into either product. To better standardize the product and improve the operator's method, the leaders decided to make the foam strips a required piece on both types of ovens. This way, the operator would have no excuses when building the part. In my opinion, this bettered the standardization process by adding the strips to the single ovens made it an even safer product since it now has increased airflow. During my internship, I was also put in charge of fixture operation sheets. These sheets included steps and pictures that showed how to operate said fixtures. These needed to be upgraded for compliance, so I took the time to go around and ensure the correct operations and instructions were posted. This was one of the biggest standardization projects that I was a part of while at Roper. The standardized paths pertain to people who worked multiple stations. They had a designated path to follow in the construction of their product. This allowed for a maximum efficiency in the plant as they were not wasting steps but routinely did the same movements quickly. Standardization is also important in many fields other than engineering. As we discussed in class, there was a standardized way of inserting the mainline IV in the medical field, which helped cut down on infections and bruising. This is just one example of how the medical field utilizes standardization. However, I would like to point out that standardization has almost become a way of life for some people who are working on the front lines of the COVID-19 pandemic. Most hospital and medical facility workers have been provided with a standardized way of living and working. For instance, my fiance's mother works at a local medical facility, which now requires them to wear a mask and gloves while at work. They also get their temperature checked each time they enter the building. She has also been told to clean her shoes, wash her clothes, and shower as soon as she comes home from work. While this may seem like a very loose version of standardization, it still promotes the lean culture, but with people. The more employees that follow these standards, the less waste the company has with absences and potential shutdowns due to the virus. Standardization is also important in education on all levels. My fiancée is a 9th grade English teacher. She puts specific timelines and guidelines in her day-to-day lessons that require her students to perform at their highest ability. Once they get used to this practice of following basically the same schedule each day, the amount of time wasted is very minimal. I have included the overview as an example. If you replace worker with student and leader with teacher, you will see just how similar the standardization process is. As with factory standardization, she, as the teacher/leader, is always looking for feedback in order to improve the standardization of the classroom. One thing I have learned during my time in this class and while creating this presentation is that standardization is not just a foundation for lean culture, but in many ways can be a foundation for life. Of course, life isn't standard, but by standardizing plans, budgets, and everyday processes, we can all eliminate waste in the most efficient way possible.